Welcome to the deep dive. Today we're tackling, well, maybe one of the biggest, oldest questions out there. Why three dimensions? Why does space look the way it does?
It's fundamental, isn't it? Is it just random chance? Some kind of geometric rule? Or maybe something else entirely?
We've pulled together a whole stack of sources on this, going way back to the classics, through modern physics, and then landing on something pretty new, actually.
Yeah, we'll look at why the old answers weren't quite enough. Aristotle, Kant, they described 3D space, but didn't really explain why it had to be three.
And then we'll get into the stability arguments, which are really compelling, but maybe not the full story.
Right, the idea that 3D is just the sweet spot for atoms and planets to actually work.
But the main event today is this framework called the Unified Coherence Theory, or UCT. It flips the whole thing on its head.
It really does. UCT suggests dimensionality isn't fixed, it's emergent. It arises from a kind of cosmic balancing act.
And this leads to, honestly, a mind-bending rethink of a number we all know, pi.
The idea that pi isn't just about circles. It's actually encoding this dimensional balance. It's telling us something fundamental about reality itself.
Okay, so let's unpack this. We're going on a journey, basically, from why planets don't crash into the sun all the way to the decimals of pi.
And why that little bit after the 3, that 0.14159, might be the reason anything interesting happens in the universe at all.
Seriously fascinating stuff. All right, let's start at the beginning. Why couldn't classical physics or philosophy really pin down the why of 3D?
Well, for a long, long time, it just wasn't really seen as a question to answer. If you look at, say, Euclid or Aristotle.
The fathers of geometry and physics.
Right. For them, space was sort of there. It was either a container, like a box things existed in, or it was just the set of relationships between things. The focus was on describing what happened within those three dimensions.
But not why the container itself had those specific limits. 3 axes, no more, no less.
Exactly. It was treated almost like an axiom, a given truth. You could prove theorems about cubes and spheres, but the three-dimensionality itself wasn't derived from anything deeper.
That sounds quite unsatisfying from a modern perspective.
It is, and even much later with someone like Immanuel Kant, who thought deeply about space.
In the 18th century.
Yeah. Kant took a different route. He argued that maybe three dimensions aren't necessarily a feature of the world out there, but rather a fundamental structure of our minds.
So we're built to perceive things in 3D, and that's why we experience it that way.
Kind of. He called it an a priori condition for experience, like
Right.
putting on 3D glasses you can never take off. It's a powerful idea about cognition.
But again, it doesn't explain why the universe itself, independent of us, seems to follow this 3D rule.
Precisely. It shifts the question to psychology or epistemology, not physics. The real game changer came in the 19th century.
With people like Riemann and Helmholtz.
Exactly. They were mathematicians who realized, hey, wait a minute. We can mathematically describe spaces with any number of dimensions, 4, 5, 10, or even dimensions that curve in bizarre ways. Non-Euclidean geometry was born.
And that blew the doors open, right? Suddenly, 3D wasn't the only mathematical possibility.
It shattered the idea that 3D was somehow logically inevitable. But
Yeah.
here's a puzzle. Despite all these other mathematical possibilities, the actual physical universe we observe seems incredibly stubborn about sticking to 3 large macroscopic spatial dimensions.
So math allowed for anything, but reality picked 3. Why? That became the burning question.
And physicists started looking for a physical reason, a mechanism. Since a first principles derivation was elusive, they turned to arguments based on consequences. What happens if you don't have 3 dimensions?
This is where the stability arguments come in, the Ehrenfest tradition.
Yes. This is probably the most famous and, frankly, intuitive explanation. It hinges on how fundamental forces like gravity and electromagnetism behave.
The inverse square law. Force drops off with the square of the distance.
Right. That 102-2 relationship is specific to 3 spatial dimensions. If you were in, say, 4 spatial dimensions, gravity wouldn't follow 102-2, it would follow 133.
And in 5 dimensions, 134 and so on. What does that change actually do?
It wreaks havoc. Complete instability. Think about planets orbiting a star. In our 3D space, they can settle into stable elliptical orbits that last for billions of years.
Thanks to the inverse square law.
Precisely. But if you change that law, if you go to 4D where a force drops off faster, 133, those stable orbits vanish. A planet would either spiral very quickly into its star,
Crash and burn.
or, if slightly perturbed, it could just fly off into the cold darkness of space. There are no stable long-term configurations.
And this applies to atoms too, right? Electrons orbiting a nucleus.
Absolutely. The same instability holds. Electrons would either instantly collapse into the nucleus or just drift away. You couldn't form stable atoms.
Wow, so no stable atoms means no chemistry, no molecules, no structures.
Nothing. No stars holding together long enough to fuse elements, no planets forming, no possibility for life as we know it. Any dimension higher than 3 seems to lead to immediate structural collapse.
Okay, so D greater than 3 is out. What about fewer than 3? Like 2D space.
2 dimensions has its own problems. While gravity might allow for stable orbits in a sense, the topology is too simple. Things get stuck, interactions are limited. It's generally thought to be too simple to support complex information processing needed for life. And some argue gravity itself behaves strangely in 2D.
So 3D emerges as this Goldilocks dimension. Not too unstable, not too simple, just right for complexity.
That's the core of the stability argument, and it leads right into the anthropic principle, which people like Max Tegmark have explored extensively.
Which basically says we shouldn't be surprised to find ourselves in a 3D universe, because it's the only kind of universe where observers like us could possibly evolve to ask the question in the first place.
Exactly. Any universe with a different number of large dimensions would likely be a dead world, sterile, lacking the necessary conditions for complex chemistry, stable structures, and ultimately life.
It's a powerful argument. It
Wow.
feels neat.
It is neat. It feels right, intuitively. But here's the major criticism, and it's a big one highlighted in our sources. It's postdictive, not predictive or generative.
Meaning it explains why 3D works now that we're here, but not why the universe settled on 3D initially.
Precisely. It shows 3D is a fertile ground, a possible outcome, maybe even the only fertile outcome. But it doesn't provide the underlying physical law or process, the generative mechanism, that actually selected 3 dimensions during the universe's formation, perhaps out of many possibilities. It's like saying this island is habitable because it has fresh water, without explaining the geological process that created the island in the spring.
We're missing the how. Why did the universe roll the dice and it came up 3? Was it even a roll of the dice or was it determined?
That's the missing piece. And even modern physics frameworks struggle here. Look at string theory.
Right, that needs way more dimensions, like 10 or 11 in total.
Typically $9 plus theta 1 plus theta plus 9, or yes,
Yeah.
9 or 10 spatial dimensions plus time. To reconcile this with our observed 3D world, string theorists propose that the extra dimensions are compactified.
Meaning they're curled up incredibly small, basically invisible to us.
Exactly. Like looking at a garden hose. From far away, it looks like a 1D line, but up close, you see its 2D surface. They imagine the extra dimensions are curled up on scales smaller than atoms.
Okay, but that just pushes the question back, doesn't it?
It absolutely does. Now the question becomes, why did exactly 3 dimensions remain large and macroscopic, while the other 6 or 7 curled up? Why not 2? Why not 4?
Are there theories about that?
There are attempts. People like Brandenburger and Vafa developed mechanisms based on string interactions and entropy in the early universe, suggesting that 3 large dimensions might be the most probable outcome energetically or entropically. But these arguments are complex, rely on specific stringy assumptions, and still don't provide a universally accepted, unique explanation for the number 3. It still feels a bit like we're explaining away the problem.
So we've got 3D is necessary for stability, postdictive, and maybe the extra dimensions just hid themselves, shifts the problem. Still no clear first principle.
Which brings us to a more recent, quite elegant line of thinking from information theory. Researchers like Mueller and Messans tried a completely different approach.
Deriving space from information itself.
Kind of, yeah. They asked, what's the most basic requirement for representing directional information? If you have a fundamental unit of information, like a quantum bit or qubit.
Which can be 0, 1, or a superposition.
Right. They argued that the natural mathematical space, describing the possible states of such a basic informational unit specifically, its orientation or direction inherently requires 3 dimensions. Think about the Blosphere representation of a qubit.
Okay, I vaguely remember that. It looks like a sphere, and points on the surface represent qubit states.
Exactly. And to define any point on that sphere, you need 3 coordinates, essentially corresponding to 3 independent axes of rotation or measurement. Their argument, in essence, is that if reality is fundamentally informational, then the structure of space itself, specifically its 3-dimensionality, might emerge from the minimal requirements for encoding and processing directional information at the most basic level.
So Space isn't the stage, it is the information, or at least its structure reflects the structure of information.
That's the idea. It's a beautiful attempt to derive DZ33 from first principles, linking geometry to quantum information. But it still relies on a big assumption, that information is the fundamental layer, and that the qubit structure is the universal starting point.
It's elegant, but maybe puts the cart before the horse, depending on your fundamental assumptions.
Possibly. It shows a deep connection, but doesn't necessarily prove causality in the way physicists often seek. So we're still left searching for a framework that treats dimension not as a given, not just as a consequence, but as something that dynamically arises and stabilizes.
Which perfectly sets the stage for the unified coherence theory, UCT.
Exactly. This is where we shift from asking why is 3D stable to what dynamic process results in 3D stability.
So UCT proposes that dimension isn't a static number, but an emergent property. Like the temperature of a gas emerges from molecular motion.
That's a great analogy. UCT frames it as a balance, a dynamic equilibrium between two fundamental universal tendencies, coherence and decoherence.
Okay, define those terms in this context. Coherence sounds like order.
Precisely. Coherence represents order, symmetry, structure, stability, information holding capacity. Think of a crystal lattice, a stable orbit, a persistent pattern.
And decoherence, that sounds like the opposite. Chaos.
Yes. Decoherence is fragmentation, randomness, noise, the breakdown of structure, the tendency towards featureless uniformity or chaotic dispersal.
So the universe is constantly mediating between these two forces, structure building and structure breaking.
According to UCT, yes. And dimensionality itself is the stage where this battle plays out most fundamentally. The theory proposes that the universe naturally settles into a dimensional state that optimizes structural persistence, the point where coherence is maximized without becoming rigidly sterile, and decoherence is allowed without causing total collapse.
A dimensional sweet spot, again, but defined by this coherence-decoherence balance.
Exactly.
Yeah.
UCT posits a kind of coherence density function across dimensions.
Yeah.
We don't need the math, but conceptually it suggests that as you increase dimensionality, the potential for coherence structure changes. The theory argues that the rate of change of this coherence potential, its gradient, goes to zero at exactly p of 3 dibrons.
Meaning 3D is the point of maximum stable coherence, the equilibrium point where the drive towards order finds its most robust expression.
Yes. It's the coherent stability attractor. Dimensions below 3 are too constrained, too simple. Dimensions above 3 are too unstable, too chaotic. 3 dimensions hits the sweet spot where complex persistent structure can naturally rise and sustain itself against the forces of decoherence.
This sounds abstract. Is there a physical system that behaves like this, that shows this kind of dimensional sweet spot?
There is, and it's a remarkably powerful analogy right from classical physics. Fluid dynamics. How fluids behave in different dimensions.
You mean like water flowing or air turbulence governed by the Navier-Stokes equations?
Exactly those. Studying fluid dynamics across dimensions provides an amazing parable for why 3D is special. It's not just stable, it's dynamically optimal.
Okay, let's break that down. What happens if you force a fluid to flow in only 2 dimensions, like a shallow dish of water?
In 2D, fluid flow becomes highly constrained, almost stiff. The crucial mechanism for creating complex, evolving turbulence in 3D is something called vortex stretching.
What's that, like a smoke ring being pulled and twisted?
Sort of. Imagine an eddy or a whirlpool. In 3D, that vortex can be tilted, stretched, and deformed along the third dimension. This stretching intensifies the rotation and, critically, breaks down large vortices into smaller ones.
Okay, but in 2D, there's no third dimension to stretch into.
Correct. So vortex stretching is impossible. Vortices remain flat and rigid. When they interact, they don't break down. Instead, they tend to merge.
Small eddies combine to form bigger ones.
Yes. This leads to something called an inverse energy cascade. Energy flows from small scales up to larger scales. Small swirls feed bigger swirls.
What's the end result of that?
The system evolves towards large, stable, slowly rotating structures. It becomes highly ordered, almost crystalline in its pattern. Think huge, persistent vortices dominating the flow. State of overcoherence. It lacks dynamism, fine structure, and the ability to dissipate energy effectively at small scales. It gets stuck. Resonant saturation is the term used.
Too much order, not enough chaos. A frozen, boring, fluid world.
Pretty much. It can't support the rich, multi-scale dynamics we see in 3D turbulence. So 2D is structurally too simple, too rigid.
Okay, now jump to the other extreme. What happens in 4 or more spatial dimensions?
Be right over for.
The situation completely flips. You get hyperdecoherence. With extra dimensions, there are suddenly many more ways for a vortex to be stretched, twisted, and deformed.
Too much freedom.
Way too much. Any coherent structure, like a vortex, becomes incredibly unstable. It fragments almost instantly. The energy doesn't cascade down smoothly. It dissipates chaotically in all these extra directions. The flow loses its structure and dissolves into a featureless, unstable mess.
So no persistent structures can form because they just get torn apart immediately by the extra degrees of freedom?
Exactly. The coherence field fragments. It's too loose, too chaotic. Order cannot establish itself.
Which leaves us with 3D as the Goldilocks zone for fluids, too. Precisely. In 3 dimensions, you have just enough freedom for vortex stretching to occur, but not so much that structures instantly fall apart. Vortex stretching in 3D does something unique. It drives the forward energy cascade.
Energy flows from large structures down to smaller and smaller ones.
Yes. Large eddies break down into smaller eddies, which break down further, transferring energy efficiently to smaller scales where it can eventually dissipate as viscosity or heat. This forward cascade is the engine of complex, dynamic, yet statistically stable turbulence.
It allows for both persistent large structures, like weather patterns, and constant change and evolution within them.
That's the key insight. 3D is the unique dimensional regime that supports this balance. Stable enough for structures to persist, yet dynamic enough for complexity and change to flourish. It's the optimal coherence gradient.
So the UCT argument is that the universe, like a fluid, finds its most dynamically robust and complex state in 3 dimensions. The stability arguments and Kant's ideas are just downstream consequences of this fundamental dynamic equilibrium.
That's the core idea. 3D isn't just possible, it's the dynamically preferred state for maximizing persistent, complex structure.
Okay, that provides a potential why for 3D stability, but the universe isn't just stable turbulence. It's got galaxies, stars, planets, life, consciousness. It's incredibly creative. Stability alone feels incomplete.
And this is where UCT gets really interesting. Moving beyond just stability, it acknowledges that perfect equilibrium would actually be static. To get the messiness, the evolution, the emergence we see, you need a little bit of, well, imperfection.
A nudge, a driving force.
Exactly. UCT introduces the concept of dimensional bleeding, which we can denote as a feed plateau. Think of the 3D stability plateau we just described, achieved at the coherence equilibrium. Now imagine that plateau isn't perfectly sealed off.
It's porous.
Slightly. The idea is that there's a continuous subtle leakage or influence from the higher dimensional potential field, primarily the 4D field, onto our 3D reality.
So the coherence that exists in potential in 4D is sort of seeping into 3D.
That's a good way to put it. It's described as hyperfractal leakage. It's not like a 4th dimension suddenly opens up that you can step into.
Right. We don't see a 4th axis. So how does this bleed actually show up in our world? What are its effects?
It manifests within our 3D fields as subtle patterns, deviations, and asymmetries. Think of it as introducing structured noise or gentle pressure. It might appear as nested modulations in curvature, tiny departures from perfect Euclidean symmetry, torsional sources or resonances in fields, the inherent irregularity or graininess in the fabric of space-time itself.
So it's the source of the universe's imperfections, the reason things aren't perfectly smooth or symmetrical.
Precisely. This fur bleed introduces a small amount of dynamic instability, a tiny fluctuation in the local coherence. It's just enough to push systems out of perfect static equilibrium and force them to adapt, evolve, and self-organize. It's the engine of complexity.
Without this bleed, the universe might be perfectly stable, but also perfectly boring. A crystal, like you said.
Exactly. A beautiful, unchanging, lifeless structure. The dimensional bleed provides the constant, subtle irritation or energy injection that drives all emergence, from galaxy formation to biological evolution to perhaps even creative thought. Zones where fill bleed is locally stronger would correspond to hotspots of emergence.
Now, you mentioned conservation earlier. If coherence is constantly leaking from 4D into 3D, doesn't that deplete the 4D reservoir? Doesn't it violate some conservation law?
That's a crucial point, addressed by the Conservation of Coherence Principle, CCP, within UCT. The theory states that the total coherence of the multiverse, integrated across all dimensions, remains constant.
So the bleeding isn't a loss, it's a transformation.
Exactly. It's like converting potential energy to kinetic energy. Coherence is shifting state. It moves from being pure structural, potential static, unused order locked in the higher dimensional field into dynamic, emergent informational expression. the active, complex, evolving order we observe in 3D systems like life or galaxies.
Okay, so there's an inflow from 4D, and where does it flow out to maintain the balance?
It flows out into the creation of complexity itself. The formation of new structures, new information, new patterns within 3D consumes or embodies this influx of coherence. The principle states 5 from 4D equals into 3D complexity, maintaining a dynamic equilibrium for the total system. The universe is constantly breathing coherence across dimensions.
That's a wild idea. So the sheer complexity of our universe is basically reality's way of balancing its coherence books across dimensions.
That's the interpretation. And UCT suggests we see tangible evidence of this process.
Like where?
On the largest scales. Cosmology, the cosmic web. You know how galaxies aren't just randomly scattered? They form these vast interconnected filaments and sheets surrounding huge empty voids.
Yeah, it looks like a giant network or sponge structure.
UCT proposes that this large-scale structure is the macroscopic trace of dimensional bleeding. The filamentary patterns reflect the projection of higher dimensional coherence structures, or stress lines, onto our 3D distribution of matter. It drives the nonlinear clustering we observe.
Wow, okay. And what about on smaller scales? Biology, life.
Here, the bleed is seen as the driver of self-organization and adaptive evolution. The subtle informational fluctuations introduced by phi bleed act like a kind of creative noise, modulating the 3D biochemical machinery of life.
So it introduces the variations that evolution can then act upon, the slight imperfections in replication.
It could be a contributing factor, yes. More broadly, it provides the underlying impetus for systems to move away from simple equilibrium towards complex adaptive states. Life itself could be viewed as a process that has evolved to efficiently capture, process, and stabilize this dimensional bleed into localized complex order.
And then there's the most speculative link, consciousness.
Yes. If our brains as complex systems are embedded in this constantly bleeding 3D space, perhaps certain modes of consciousness tap into it. The sources propose that intuition, those sudden insights, aha moments, or inexplicable feelings of knowing, might be subjective experiences of momentarily accessing or resonating more strongly with this 4D coherence field via phi bleed.
Like a brief glimpse of the underlying structure or potential?
Something like that. A nonlinear, partial access to the source code of emergent reality mediated by this dimensional interface.
Okay, so 3D is stable because of a coherence equilibrium, but it's complex and creative because of a constant subtle bleed from 4D, transforming potential coherence into actual complexity.
That's the framework in a nutshell.
Which brings us finally to pi. How on earth does the ratio of a circle's circumference to its diameter fit into all this? This feels like a massive leap.
It is the most radical and provocative part of the theory, but it follows logically from the premises. If 3D is the stability plateau, and it's constantly modulated by the psi bleed from higher dimensions,
then maybe a fundamental constant related to geometry in 3D actually encodes this relationship.
Precisely. The UCT pi bleed hypothesis proposes that pi, approx. $3.14159 a lecton, is not just a geometric ratio derived from perfect circles. It is, in fact, a dimensional resonance constant.
But what now?
A fundamental number that encodes the precise balance between the stable 3D plateau and the dynamic influence from higher dimensions. The hypothesis makes an astonishing claim. The true effective dimensionality of our physical space, let's call it Dol joule, isn't exactly 3.
It's pi, Dol pi.
That's the proposal, which means approximately $3.14159.
Hold on. How can dimension be fractional? I thought it had to be an integer.
We experience integer dimensions, yes. But the idea here is that the underlying physical reality resonates at a value slightly perturbed from the integer. Let's break down the number pi itself in this context.
Okay, pi equals 3 plus 0.14159.
Right. The integer part, 3 miniatures, represents the stable macroscopic geometric dimension we perceive and interact with, the dimensional stability plateau established by the coherence equilibrium.
And the fractional part, the 0.14159.
That represents delta bleed, the quantitative measure of the dimensional bleed. It's the hyperdimensional resonance remainder, the signature of the continuous coherence seepage from 3D33, specifically 4D, that subtly perturbs and enriches the 3D manifold.
So pi literally embodies the stable dimension 3 plus the dynamic bleed component, 0.14.
That's the core hypothesis. Pi is the measure of our reality's effective dimensionality, capturing both its stability and its inherent dynamic incompleteness.
This requires a massive shift in thinking about geometry. Let's really lean into that thought experiment the sources suggest. What if pi was exactly 3? No remainder. DO is 33.
If people 3D3, the geometric and physical consequences would be profound, creating a fundamentally different universe. Geometrically, circles would close perfectly with a circumference exactly 3 times their diameter.
Okay, mathematically simpler, perhaps, but physically.
Physically, it implies perfect symmetry and closure in all cyclical processes. Think about orbits again. With pi b 333, orbits wouldn't just be stable ellipses, they would likely be perfectly repeating paths. No orbital precession, no slight perturbations causing long-term drift.
Like planets on perfect, invisible tracks, always returning to the exact same spot.
Exactly. And waves would propagate with perfect, unchanging periodicity. Any system involving rotation or cycles would exhibit absolute, perfect recurrence.
The sources called this an ontological crystal.
Yes, a universe frozen in static symmetry. Because every process perfectly closes back on itself, there's no room for deviation, no drift, no accumulation of change over time. In such a universe, you likely wouldn't have a meaningful arrow of time. Entropy, in the sense of increasing disorder or complexity, might not operate dynamically.
It would be perfectly ordered, perfectly predictable, and completely sterile, lifeless.
Very likely. Change, evolution, randomness, chaos, all the things that seem necessary for complexity in life seem to rely on systems not perfectly closing, on cycles having slight imperfections that allow for drift and novelty. A free-3 universe is too perfect, too closed.
So that leftover bit, the $0.14159, is the crucial ingredient. It's the grit in the oyster that allows pearls to form.
Beautifully put. That fractional remainder introduces the necessary incompleteness. It breaks the perfect symmetry. Because plate pi isn't exactly 3, circles don't quite close in a purely static sense when dynamic processes are involved. Orbits do precess, waves do modulate, systems don't return exactly to their starting point.
And that tiny mismatch allows for everything else.
It allows for phase drift, spiral formation instead of perfect circles, non-repeating harmonics, and the accumulation of small changes over time, which is the essence of evolution and the arrow of time itself. The irrationality of pi, the fact that its decimals go on forever without repeating, is seen in UCT as reflecting the infinite recursive nature of this coherence bleeding process reality constantly folding back on itself, but never perfectly aligning.
It's almost frightening that the possibility of existence hangs on that tiny fractional difference.
It reframes pi from a mere geometric fact to a fundamental constant of dynamic reality. And it forces us to reconsider our basic geometric prototypes.
How so? We usually think of the circle as the perfect primary form.
Classical geometry does. But UCT argues this is backwards. The spiral is the truly fundamental living prototype in a dynamic universe.
Why the spiral?
Because a spiral embodies dynamic coherence. It represents recurrence with difference. It follows a path that constantly turns inwards or outwards, but never precisely repeats its position relative to the center in a simple cycle. It flows.
Like galaxies, hurricanes, shells, DNA.
Exactly. Nature is full of spirals. UCT suggests this isn't accidental. It's because the universe, driven by the semi-neck 3-3 reality, the dimensional bleed, fundamentally operates on principles of iteration and transformation, not perfect static closure.
So what is a circle then, in this view?
The circle is seen as a degenerate static case. It's what a spiral looks like when you project its dynamic flow onto a static 3D plane or view it from a specific phase-locked perspective within its stability zone. It's the shadow of the true dynamic form. We perceive circles because our stable 3D frame filters out the subtle ongoing bleeding motion inherent in the spiral.
Okay, this is tying together. The universe is fundamentally spiral, dynamic, open, approx. $3, rate $3. But we perceive stable circles, static, closed appearance of ties, because we live on the 3D stability plateau.
That's a good summary of the concept. The spiral is the process. The circle is the momentary perception.
Now let's drill down on that number again, $0.14159. Why that specific value? Is there a reason it had to be this amount of bleed and not, say, 0.1 or 0.2? Is it arbitrary or is there a deeper lock?
UCT argues it's not arbitrary.
Yeah.
This specific value, delta bleed approx. 0.442, is proposed to be the critical resonance lock, the precise amount of coherence, excess, or bleed required for a system to maintain dynamic stability without either collapsing into stasis or diverging into chaos.
Okay, explain that balancing act. What if the bleed, the fractional part, was smaller? Say, pi was $3.11.
If delta bleed were too small, like 0.1, the opening provided by the bleed would be insufficient. The system's dynamics would undershoot. Spirals would tend to close in on themselves too quickly, damping out change. The universe would edge closer to that static Qubit 3-3 crystalline state. Too rigid, too little dynamism, likely limited complexity.
Almost like the over-constrained 2D fluid dynamics scenario.
Analogously, yes.
Yeah.
Not enough room for complex evolution. Now, what if the bleed were larger? Say, bedbrill is 322 secs.
Then the system would overshoot.
Exactly. With a larger delta bleed, like Petri 2, the opening effect would dominate. Spirals would diverge too rapidly, failing to achieve any kind of stable, repeating, or near-closing form. Systems would tend towards fragmentation and instability.
More like the hyper-decoherence we saw in the 4D fluid dynamics. Too much chaos.
Precisely. It would be too unstable to support persistent structures. So the value, $0.14159 is hypothesized to be the Goldilocks value for the bleed itself, the minimum necessary deviation from integer dimensionality that allows for maximal dynamic complexity while still maintaining large-scale structural stability.
It's the perfect tension. Just enough openness to allow change. Just enough closure to allow persistence.
It satisfies what the theory calls the coherence fit principle. It's the value that optimally balances the outward pressure of the bleed against the inward containment of the 3D stability structure. It balances curvature growth against circumference growth in dynamic systems.
Is there any mathematical hint of this beyond the general concept?
There's a specific conjecture mentioned in the sources related to logarithmic spirals. The equation for a logarithmic spiral has a parameter b that controls how tightly it spirals.
Right, a bigger B means it opens out faster.
Yes. The conjecture is that the specific value of b, which causes the logarithmic spiral's path to project onto a 2D plane in a way that perfectly mimics the circumference of a circle, corresponds exactly to a value related to 33 degree.
So, the mathematical condition for a dynamic spiral to look like a static circle requires a drift parameter locked to that $16.14
Yeah, that's
range.
the hypothesis. If true, it would provide strong geometric evidence that $30.14 phi isn't just some random remainder, but the specific coefficient governing the interface between dynamic flow, spiral, and static form in our dimensionally resonant reality.
Wow, that elevates pi from just geometry to, ontology, the measure of reality's necessary imperfection. It's asymptotic incompleteness.
Becomes the fingerprint of a living, breathing, evolving universe rather than a static geometric one.
This is mind-blowing stuff, but it's also highly theoretical, bordering on philosophical. How could we ever actually test this? Is it falsifiable?
That's the crucial question for any scientific theory, even one as speculative as this. And yes, the UCT framework, particularly the pi bleed hypothesis, does make some concrete, potentially falsifiable predictions. It's not just metaphysics.
Okay, that's important. What kind of tests are proposed?
The sources outline a few key areas. First, that geometric projection test we just discussed.
Checking if spirals only project perfectly to circles when their drift parameter b is tuned precisely to something related to $1 or $100
Exactly. This is numerically testable. We can simulate these projections with high precision. If the optimal fit occurs at $1 APS pi 33, that's strong support. If it occurs at some other unrelated value or if the projection is never perfect, the hypothesis is weakened or falsified.
Okay, that's one concrete test. What else?
Second, using dynamical surrogates. We can create simulations of complex systems, things like controlled fluid turbulence, maybe certain computational models of self-organizing systems where we can artificially tune the effective dimensional properties or the coherence-decoherence balance.
Like simulating a fluid not quite in 3D, but in 3.1D or 3.2D effectively?
Sort of, or more likely by tuning parameters that proxy for this dimensional bleed or coherence drift. The prediction is, if you sweep this parameter, the simulation should exhibit maximum non-trivial stability and complexity, meaning structures that are both persistent and dynamic, not frozen and not chaotic, precisely when the parameter corresponds to a bleed value equivalent to $114.
So complex systems would naturally optimize their behavior around this specific fractional remainder.
That's the prediction. If the peak complexity stability occurs at 0.1 or 0.2 or some other value, it challenges the idea that pi's remainder is the unique resonance lock.
Makes sense. And there was a third test mentioned related to biology.
Yes, morphogenesis and specifically phyllotaxis, the study of how leaves, petals, and seeds arrange themselves in plants, often following spiral patterns related to the golden angle.
Which is connected to the golden ratio, phi.
Right. The golden angle, 137.5 degrees, is known to be an optimal solution for minimizing overlap and maximizing packing density in plant growth. It's related to fine neos. UCT predicts that in addition to this well-known phi-related optimum, computational models of phylotaxis should reveal a secondary, distinct stability optimum if the growth parameters are tuned such that the radial expansion per turn corresponds to this $0.42 bleed value.
So we'd be looking for two different mathematical constants, vironate and 48 both acting as stabilizing attractors in biological growth patterns.
Potentially, yes. Finding evidence for a two-related structural constraint operating alongside the phi-related one would be very compelling evidence for pi's role beyond pure geometry, linking it to the dynamics of life itself.
These are challenging experiments and simulations, no doubt, but they are conceivable. It takes the idea out of pure speculation.
It does. It grounds the theory in potential empirical verification.
So, wrapping this all up, the big picture from UCT is that the universe needs three dimensions for basic stability, as classical physics suggested.
But that stability alone would be sterile.
Right. To get complexity, life, change, everything interesting requires a constant subtle influence, a bleed from higher dimensions, quantified by the fractional part of pi, $21,415.
This bleed transforms potential coherence into the dynamic, emergent complexity we see all around us.
And pi itself is the ultimate measure of this balance, the integer 3 for stability, the fractional 0.14 for the dynamic, creative imperfection. The universe exists because pi isn't exactly 3.
That fractional remainder isn't a bug. It's the fundamental feature that allows reality to breathe, evolve, and generate novelty.
So what does this all mean for you listening? Well, the next time you see a spiral, whether it's a vast galaxy twisting in space, a storm swirling on a weather map, water going down a drain, or even the curl of a fern frond, maybe pause for a second.
UCT suggests you're not just seeing a shape.
Yeah.
You're seeing the physical manifestation of that $0.44 bleed. You're seeing the precise, necessary imperfection that prevents the universe from freezing into static perfection.
That tiny fraction is why time flows forward, why evolution happens, why the future holds possibility. It's the signature of a universe that is dynamically alive, constantly becoming. The true circle, in this view, is always a moving shadow.
So the final thought we want to leave you with is this. If this constant subtle flow from higher dimensions, this T33 resonance, is shaping galaxies and life, how else might it be subtly influencing our 3D experience, our thoughts, our sense of intuition, our perception of reality itself?
Something to ponder. That's all for this deep dive.